There are two more microphones at live. Do you
there we go. Okay. Terrific. Okay, well, let's just leave them here, and I'll hand them out if people need them. So, okay, thank you. Yeah. That'd be awesome. You probably don't need to sit by the microphone since you know most people. Because the reason that it's important is because Maddie, who's taking the notes, doesn't know people's faces, so she'll be relying on the Jabber room for that business. Are you taking them in Etherpad? Did anybody point you to the Etherpad? Can somebody point Maddie to the Etherpad? Okay, yeah, it's mostly reliable. Wow, interesting resolution. Let's see if we can fix this. Yeah. More Ks. There you go. I'm sorry? Yes, would you? Thank you very much, Zad. Okay, we're running a minute late, but that's all right. We've got lots of time. Okay, blue sheets are going around. Oh, that's interesting. Yes. Isn't that nice? No, what's worse is that preview is unhappy. Okay. It's a known vulnerability, right? Should never happen. Let's try this again. Does that work? All right. Everybody, please note well the note well. There are new notes to note. I don't know. I think the RC number's changed, right? There's 8,000s now. The contents of the RCs or the contents of this text here? Yeah. Okay. Well, then I'm not going to try to paraphrase it, but my former understanding is if you say something here, it's considered to be an IETF contribution. If you say something in the hallway, it's considered to be an IETF contribution. If you send something to the Jabber list or the mailing list, it's an IETF contribution. So that's public disclosure. Might want to think about that. Okay. That's interesting. We'll get through them twice as fast that way. Let's try it this way. Oh, there goes the beach ball again. Wow. I need to force quit. That's right. I'm not going to say anything about where the source of the problem is. It's probably me. Also not what I expected. Single page. Full screen. Okay, here we go. Wow. Yeah, the slides are. Oh, yeah. Thank goodness somebody's got a Windows machine. Yep, there we go. Okay, let's see. Okay, that's a little better. Great. All this for what is basically one slide. So let me start out. I think everybody knows me. I'm Aaron Falk, and this is Zayed, who I'm not going to try to pronounce your, say your name.
Janet Jaman Sharkar.
Thank you. Co-chairs of TAPS, Transport Services. If you're in this room, you've probably been involved for a while because this is, I think we're in our third year. This is a little bit of status on what's going on with the working group. We are, we've published several documents that all contribute to what we're calling Milestone 1, which is an analysis of transport protocols in an attempt to come up with a standard set of terminology that will allow us to derive an abstract API for transport features and functions. We published one RFC. We announced that at the last IETF. Since then, we finalized and held a last call on a set of usage documents that refine this analysis and come up with some nomenclature for how to refer to various transport features. Those are separated into two documents because they had really two different author sets, one for TCP and SCTP and another one for UDP and UDP Lite. Plus, there's other stuff in there besides those, but that's most of it. Those documents have completed working group last call. Zod has been working on the document shepherds write-up, and I think we're going to get those to Spencer hopefully this week. I think what's missing is that I need to review it, and Spencer will read them, and then something good will happen. So that's the first of the. I think that completes the first of the three milestones. I think there's an open question about whether we want to add some of the security stuff that we're going to be talking about today to that as well. I certainly think we want to publish it. Yeah, Gori.
Gori Fairhurst, author of the UDP usage. We got comments from Zayhed, and we've just submitted a new rev of that to reply to those comments.
Oh, thank you. Yeah, I saw that come by. That's great. Yeah, I expect that there'll probably be some version number increments as we do some of the final polishing on this. So the second milestone, yes, Mirja.
Just remind me, did we decide to keep them separately or merge them finally?
We decided to keep them separate, so they're going to be published as separate RFCs, but as a pair.
Why?
It was just more practical for the authors to manage them. And they're pretty big documents.
Gori Fairhurst again. Yeah, another reason I quite liked having them separate was because I think the audience of the two documents is different. There's a lot of people in apps use UDP, whereas a lot of people take the other transports just as TCP or SCTP or whatever and just run things over it. So I think maybe the audience is different, and publishing as a pair seems cool.
I'm okay. I just thought the goal is to get like a common interface at the end.
Okay, we have a conversation. Yes, that's probably true, but there is the documentation for anything to do with UDP dates from the time we built the ARC, and therefore this is probably the first time I've ever gathered this stuff together. I think people might well think that's helpful, even if they're not doing TAPS.
We actually discussed this a couple of times, and there hasn't been a big push to try to combine the documents, and it would be be a significant amount of effort. So since no one's asking for it. Okay, so moving on to milestone 2. Milestone 2 is to take what milestone 1 did was it went through all the transport protocols in IETF standards plus some additional ones that folks wanted to focus on, and deliberately excluded security because we didn't have anybody at the time who wanted to work on it, and then come up with a standard set of description of features and systems. Are you looking for the radio? Yeah, no, I think it's actually there's a radio in the hallway or something.
We heard the background music.
Yeah, it'd be awesome if you could find it. Makes me want to dance. So milestone 2 was about taking that long list of description of features and trying to come up with a minimal set of recommended features that a TAPS subsystem should support. And so this the idea was that if you had multiple implementers who are doing TAPS, that they're at least sort of supporting a common set of useful stuff. And so it's a recommendation doc, but it's a recommendation doc for implementers of TAPS. And so we're going to hear a discussion today on current version of that draft, which is kind of stabilizing now, and hasn't been adopted as a working group. That seems like an oversight. We should just, I think we should make a decision today if we're going to adopt it, because we don't have an alternate document in progress. So I was really happy at the last IETF. Tommy from Apple and brought some friends of his and agreed to take a look at the transport security protocols and try to apply the same analysis methodology that we did on the on basically the data side of the transport protocols to the security protocols, so that we can come up with sort of a add to the language that we're building for the abstract API, the ability to talk about different kinds of security services. There's several really useful implementation efforts underway. I think we've already learned a lot about that. We're going to hear a discussion about a couple of those projects today. And now that we've gotten, people are starting to build these things, and they are talking about the mechanisms for detecting what transport protocols work end-to-end and making decisions about selecting one over the other, assuming an application uses these abstractions to describe what kind of behavior it wants. We need some way of expressing preferences and remembering past behaviors and reasoning about how one chooses among the options of what's going to work end-to-end. And so we're really starting a discussion today about policy. One of the things that I would like to start thinking about today as a group is, what is the output of this activity going to be now that we've sort of got the language to talk about these things? Are we going to just sort of write some RFCs that describes the various implementation projects? Do we have enough of a consensus that we make some recommendations for what someone should do in a TAPS system? Can we agree on some aspects of this? And so that's the kind of thing that I'm going to be listening for out of this, and maybe try to propose some additional documents as work items. Here's the schedule. This is the first time I think that I've shown a schedule that I hadn't had to go back and change the lowest significant digit on the years. So I think maybe I'm getting more realistic. So I think that we're going to finish Doc 1 today. Milestone 2, I think, assuming that we adopt MinSet and it's kind of stabilizing, that we hopefully will be able to get that last called around the next IETF. And then that gives us one more cycle for the thing that comes later, and I don't think we know exactly what that is yet. So that's probably going to push out a little bit. Now rolling back to the agenda, which I kind of skipped over here. This is the working group status discussion that we've been having. Next, Naeem, are you? Thank you. Naeem's going to talk about the MIN set of transport services that the authors, Michael and who's the other author? Aren't able to make it today, so he's going to give an overview of what's going on from that team. Chris and Tommy are going to talk about the transport security protocol analysis, and there's a bunch of open questions to discuss about how we want to treat that stuff. Philip Teasel is going to talk about socket intents. It's come up a few times in the past, and that's a project that's continuing to mature. Same thing, Anna's going to talk about the Happy Eyeballs project. And then hopefully we're going to have about roughly an hour to talk about policy. I don't know if we're going to need all that time, but I think that it's good to have a little bit of a unstructured area so we can sort of see where that discussion is going to go. Any comments or questions on the agenda? Is there anything that people want to put on here that they don't see? Any high-level comments about the direction of the working group that you want to fire the chairs or something? Okay. Well, you had your chance. Let's see. I don't know how I'm going to do this. That's not right. There we go. Min set. Do you want to drive or do you want me to drive? You can drive? Oh, I drive. Okay, great. So just, all right.
So this is the draft Yessing TAPS min set. I would like to note that I'm not an author of this draft, so I'm presenting on behalf of Stein Yessing and Michael Wells.
Look down.
Yeah,
Those are
I'm
your
saying
signs.
Got it. Yeah. So Michael should be online. So if any questions regarding discussions around this draft, it should be primarily addressed to him. So hopefully he will be able to answer, or I will try to answer. So next. So basically what is the context of this draft is basically trying to address the charter to the item 2 of the TAPS charter, which tries to specify the subset of transport services that are defined in the item 1, that end systems that support TAPS, they basically provide them, and it gives guidance to them to choosing among these available mechanisms and protocols. So the main point here is that we don't necessarily need to expose all the transport services, all the capabilities of all the IETF transport protocols into this minimum set. So it's basically a minimum set that needs to to provide the services that we think that are important to have. So why it's a minimal set is basically because we don't want to expose everything. And why we don't want to expose everything? 2 main reasons is that first, it will create a very complicated API. So it will be very difficult for the application programmer to use it. And the second is that it basically basically it ties us to a specific protocol selection. So if we have lots of transport features there to expose, you may end up in a situation where you go on selecting a specific transport protocol all the time. So we want to make things as automatable as possible. So this draft is basically based on 2 other drafts. So it's driven based on the methodology that were defined, the 3 phases that were defined in the IETF TAPS transport usage drafts. The one that covers anything but UDP, and then the other one that covers the UDP ones. Next. So this is the revision 05. The main changes since the 04 was that now, before it used to be that we had all the mechanism to derive this minimum set at the beginning of the draft. Right now you have the textual description of the minimum set and the abstract API at the beginning, and then you have the mechanism appearing as an appendix. The mechanisms to derive this is basically a 3-step or 4-step mechanism. First of all, you basically categorize these transport features or transport services. You categorize them into 3 categories. There are things that are functional, which means that the application basically assumes these things are working. For example, an application has an assumption that things are going in order delivery. So the application is written for in order delivery. And if you have out of order delivery, then the application doesn't understand it. So it's a functional thing, and the application breaks. So there's this category of functional. And then there are things that the application is better to know about it. And these are for optimization. For example, changing the DSCP value. And then there are things that you can automatize without specific information from the application. For example, the CTP multi-streaming. And then once you have all these categories, then you go to another step, which is called the reduction. And in the reduction, you remove basically the automatable set or category from the list. And basically the features that they don't require the application specific knowledge. Or we assume that we should always be able to fall back to TCP. That's the assumption we take. We ideally better to be able to fall back either to TCP or UDP. In this case, we assume that we always want to fall back to TCP. So if anything prohibits falling back to TCP, it's something that you don't want to expose. That's the reduction step. So two major, basically, criteria to reduce the list. And then once we have that, then we have some cases of peculiarities. For example, as I will explain later, there is a case where you want to send a message but receive a stream. Or for example, you don't expose multi-streaming, but you want to have the ability to assign a per stream priority. Next, please. So once you have all of that, then you end up having a min set, basically a minimum set of transport features that you want to expose. The high-level view of this is that, so there are certain basically aspects of it. Is that first, every time you start with the creation of the flow and also the creation of a flow grouping. So the reason we need the groups is mostly in case of, for example, SCTP. There are things that for example, a TAPS flow can end up being an SCTP stream or a TCP connection. So you want to be able to differentiate between those by having the notion of grouping the flows. So all the TAPS flows that belong to the same group, they basically, in this example, they will end up being in a SCTP association. Whereas in the TCP case, you could basically configure this in a different way. For example, if you want to do couple congestion control over them, then you could have a flow grouping, and that's something you want to be able to expose. An application can assign a flow group number, and that you do that at the beginning of the flow creation. For example, one of the things is that you can't really configure a timeout for a specific stream in a CTP association. So you want to be able to do that at the flow group level. Ideally, you would like to be able to use these two. You like to be able to create the flows before actually you connect. And you would like to also be able to send data before you connect. So it could be a parameter that you use to be able to send data before the connect, or you would be able to basically specify a notion of idempotent. So the idempotent, once it's been specified by the application, it allows to use a TFO or anything that resembles TFO in other protocols. So you'll be able to already send data either in the connection establishment, in the SYN packets, for example, or even before that, just before you start connecting, you just send the data down the stack. Then you have the limited, basically, notion of the connect and listen and close and abort semantics in the draft. This is mainly because to support UDP and the streams, because we don't have the notion of connect in the UDP, so to be able to have that. And also there was one thing that Michael presented in the last IETF, and that was the notion of being able to send messages but then receiving streams. And the reason for that is that, yes, so you want to be able to fall back to TCP in any case. And if you have a UDP application, what happens is that the UDP application, when it sends a message at the receive side, it's not able to fall back to TCP. So to be able to do that, you want to have a notion of being able to send a message and also receive the byte stream. So that that was basically presented in details in the previous IETF. So if you want to have more details on that, you can just refer to the presentation of Michael. And then another thing is that you want to be able to have a uniform way at the API level to access or specify the TCP low water mark or SCTP sender dry. So these things basically, they are slightly different in the way that they are basically operating over the buffer. And you want to be able to have a uniform way at the API to do that. And also there were some things about the packet sizes. So for example, when it comes to path MTU discovery, if you're changing the path underneath without the application knowing about it, then the UDP applications may break down because they don't know about the path MTU of that specific path. So the recommendation here is that if you have the don't fragment field basically set, you either don't change the path, or if you do it, let the application know about it. Next, please. So based on this high-level view, the draft basically has driven a minimum set abstract API. So this is a first try to specify an abstract API for the min set. Basically, you start with the creating a flow at the beginning using the flow group ID. Then you can configure timeouts. You can configure urgency. And in the urgency, you can have a parameter called the capacity profile and also the low watermark flag. So in the capacity profile, you could have different basically capacity profiles. For example, you have one of the profiles could be that you would have the lowest possible latency at the expense of the overhead. For example, to be able to disable the Nagel-like algorithms. You could have another mechanism that is like a scavenger kind of traffic, or you could use basically a set of profiles based on a specific DSCP values that are taken from the table. For example, a table that is in the NData in the RTC Web QoS draft. And then you would be able to configure checksum, assign priorities, be able to connect and to listen on the flow ID, close and abort, and let the other side to know about it. And basically everything at the application, it's basically sending and receiving frames. When sending frames, we should be able to set the reliability. This is as this stands right now. So the authors had a feedback from the socket intent folks that it's better to actually be able to set the reliability at the beginning of the flow creation, because we already know what kind of reliability we are expecting. So it's kind of a bit late to do it at the frame level later. So we should be able to also do it at the beginning of the flow creation, and also the receiving the frame. And next, please. So that's basically the things that you would be able to do at the API level. Also, you would be able to get notifications from the stack. For example, in case if you have excessive retransmissions, if you have an ECN, and if there is an application that leverages the use of ECN, then it would be good for our application to know that we have an ECN at the transport. Then you would be able to set the timeouts, close and aborts, and also the low watermark. You would be able to know basically when the queue is draining before actually the queue is completely empty. So you would have the setting different levels of it, or the path change, as I mentioned. Also, you should be able to query properties. For example, the maximum frame size that can be sent without fragmentation, the maximum transport frame size that can be sent, or maximum transport frame size that can be received, and also the maximum amount of the data that can be sent before actually we have the connection establishment. So send before connect. Next, please. So in conclusion, the TAP system can potentially do more than this stuff, but what we want to have is that we want to be able to have the minimum set of things that we would like to provide. There is a basically important hint here, and that is if you expose limiting functional features, you're actually limiting the ability to select these new transport protocols that we want to use. So it's better to not expose things that basically limits the choice of transport protocol. So that's basically a hint here. So what to choose and what not to choose, that's basically what the document is trying to clarify. The min set is the thing that we expose everywhere, and also we have the notion of high-level APIs versus low-level APIs. And next. So we are ready for questions, and we also have one ourselves, is that can this document be adopted as a WG item? And I believe Michael should be there, so, and I'm here too.
Before we go to questions, Michael, is there anything that you want to add as a remote participating author? No?
No.
Hello. No, nothing I want to add. But I'm here.
Okay.
Yeah.
Mirja.
Mirja Kühlerin. So I think it was actually not an oversight to not adopt it, because kind of this is a completely different document than the previous version, right? This is just something completely different. And you're going one step further, which is not wrong, but maybe not the right document to do it. I think like talking about the API, it should probably be step 3 here. So I was, if I remember correctly, I was making last time a comment that I actually want to see something else than what was in the document previously, but I wanted to see the other part. I wanted to see more discussion about what can be automated and how, and which are the things that need direct input from the application. And now Michael wants to say something.
Of course, I think I'm probably the right guy to answer. So this is just an extension of the work, and it hasn't changed actually. It was just that what you saw before was pretty unfinished. We haven't invented a new API or anything. It's just a different way of writing up the services. So this is and this final list of services that with this process you end up with. It wasn't the previous version. It was just at the end, and now we've put it in the beginning. And move the rest to the appendix to make the whole document more readable. But this API isn't inventing anything new. It's just summarizing the services the protocols currently offer. And how you would implement that, I agree that this would be good to have. But how you would implement that is what I read as chart item 3.
So you mean you're just proposing an API that is not the final API that TAPS wants to deliver?
It's not a proposal of one specific API that TAPS is gonna deliver. It's a list of services. So you can read this. We have 2 separate sections there. One is kind of like the slide that Naeem had that just talks about it in prose, and the other one is listing the same thing as an API. But that's just an abstract.
Okay,
it's just a way of looking at it.
I think I still object to having it as an API, because it's really confusing if we specify an API and then we go on later on and say this is actually not the API we want a different API.
Well, it's a minimum. So the point is that these are the functions that at least you really have to offer, or you're gonna lose some of the functionality that the protocols offer.
It's fine to have it as a textual description. I don't want to specify it as an API.
Okay, I would tend to insist, but yeah.
Okay. Hi, Brian Trammell. Hi, Michael. How you doing? Can we go actually back to the API? Yeah, here. So as I read it, there's 2 ways to read this, right? Well, there's 3 ways to read this, and I'm going to choose not to read it in the 3rd way, because if I choose to read it in the 3rd way, then I'm going to be unhappy, and I want to be happy because it's early on Tuesday morning. It's not Friday yet. I'm not ready to be unhappy. I am ready to move the mic, though. So what I see here is basically I don't actually see this as an API for the implementation of programs in, because I think it's a bit too low level. I would say that this is a supply-side API. This is after the analysis of the minimal set of things, this is the shape of the API that any. So, okay, I'm overloading API here. This is the shape of the interface that TAPS has to provide to the thing that's going to implement the API that applications are going to be implemented, correct? Like this is the low level API. This is the minimal set, and the minimal set of things that you have to be able to control in order to make TAPS work. So I agree with that statement.
It's just a list of functionality. It's not meant to be the API that you expose in that form. Exactly.
Okay. So as long as that's a clear intent, then I think that this is actually pretty sane. If the intent is to force me to write my applications in this, then I'm less happy. But I don't think that's the intent.
That's not the intent. It's a different way of presenting it to be, to make it more readable and clear what it is. But that's all it is.
So perhaps if it's not an application programmer's interface, so we should replace the name of it with something else that is a little more descriptive than API.
Yes, so I call it the min set abstract interface, and I think this whole conversation just goes away then, because this this is pretty clearly sane. And it also, like, coincidentally happens to match with sort of the knobs that we've thought from the demand side in post sockets have to be there, right? So this is actually kind of cool because it confirms, okay, these are the things we want to be able to control from up top. These are the things we can control from the bottom. Yay, they match. You know, there's a little glue that has to happen.
Yeah, yeah.
If this list were significantly different than that, then I would say that one of the two sides has it wrong, but I don't think we do. So this is actually pretty cool. I think that this whole conversation just goes away and all the discomfort goes away if it's just the min-set abstract interface.
Yeah, yeah, I don't mind that. That's not a problem. So I see the role of this document not in presenting an alternative API rather than say post sockets, but to be able to nag you people to be able to say this functionality. If you're not putting this in post sockets, then we're never going to be able to offer it. And that's the whole procedure on how we arrived at the list and so forth. That's all it is. So I think.
Okay, cool. Then I'm super happy with this. Thank you.
Tommy Polly. Yes, so I agree with that. I think as essentially, I see it as the distilled interface, right? Like if we saw the interface that you would create from the full usage document and you tried to make an API out of that, that would be really terrible because it has way too many options. This is like the distilled version, which is like actually you can think about. So, I mean, to that end, I mean, we haven't responded yet, but I think that this should be adopted as a working group document. If for no other reason, then it's the right starting point. And if we have it in the working group, then we can cut out things or edit things properly. But it has the right core. So it's good for that reason. Just a couple specific comments based on the document and based on the presentation here. The idea of things falling back to TCP and kind of requiring falling back to TCP, I think feels a little bit too specific. I don't know if we could express it as far as saying that things fall back to, just like a byte stream, or essentially when I see what the interface falls back to, it's not really TCP specific. It doesn't have it's not like I should be able to expose all the TCP options. It's just kind of receiving a stream of data is the fundamental thing you're getting at.
As opposed to the other ubiquitous stream-based reliable transport protocols?
Well, I mean, to that end, like we're going to get into security stuff, there's no reason that min-set couldn't work. Like a TLS interface is very, very similar in its byte stream to what you get in TCP, right? So essentially what we're falling back to is just a reliable stream of bytes that is a connected thing. And so we're forcing UDP into this connected thing. So we're just saying, let's force things into 5-tuple connected streams of bytes going back and forth as the minimal.
So you're not objecting to the mechanism, you're just saying TCP as opposed to that there are other options like TLS that could work.
Right, like this abstract API is actually more general than just saying it's a fallback to TCP.
So Michael can say this himself if he feels that way, but I think the idea of calling it the thinking of this as a minimum set is to saying TCP, but also other things. I mean, would you suggest that it would be acceptable to have an implementation that only fell back to TLS and did not fall back to TCP?
Sure. Yeah. I think that's fine.
Okay.
So I think the other part also, like when there's the parts in the draft that discuss kind of like the send message and receive the stream, and goes into actually calls out post sockets and says is the other side a TAPS implementation or not. Those areas I find a little bit confusing, or like they go a little bit too much into the detail of how this is actually going to be deployed and how the interface is used. And I'd like to see those potentially removed from the min set. I don't know, Michael, what do you think about that?
Yeah, so there are. I mean, I see the point. I see that you want to have this at a higher layer and then somehow be able to move to TLS if you want to. Some of the stuff that's there is got to be there just to explain how things are going to work. So, for instance, this. I mean, I can't allow hiding screens and not have this abstraction and talk about different priorities and all that without explaining how that could potentially work. We were thinking of doing another draft that explains how you could implement the min set. That doesn't mean that this is the implementation of all that TAPS is going to do. It's just we want to implement that subset of functionality that min set offers, which is just to be able to use, say, SCTP, TCP, the protocols we have with supporting it. This is how you would have to do it. So some of these specifics just come from the necessity of it being implementable.
Yes, but I think maybe another way to phrase what I'm saying is that we're assuming that when we bring up this connection, that the application that's using this minset API doesn't, it really doesn't know what ended up choosing, right?
Right.
And so maybe that's something that needs to be added here, because I can create this, I can maybe not care which protocol ends up being created, but at the end of the day, it does choose one and connects on one. And if the application knew which one it ended up choosing, you wouldn't necessarily need this oh yeah, I can receive a byte stream, because if it ended up doing UDP, then great, you're going to get frames back. And we could potentially think about how the minset API works.
But that's
I think there are ways to represent it correctly.
That's not the minimum set anymore. You want to add this type of functionality and make it a bit more dependent on the protocol, because the application then makes a decision to say, okay, it tells me that it's not a byte stream, and then I have to do something differently, and you put this in the API as an added functionality if you want. But technically, so this minset.
Michael, let me interrupt.
Sorry.
Let me interrupt for a second, Michael. Tommy, high order bit. Do you oppose to making this a working group document? You said yes. Okay, just trying to confirm that. I'm looking at the time, and I don't want to get too into the details. I'm really happy to see substantive discussion on this, but I think that at this point, what I'd like to do is focus the commentary as to whether you're supportive or have strong objections to whether this should become a working group document. Yeah, as it is, or identify things that you think would need to change in order for it to do so. Now, Spencer.
Spencer Dawkins says responsible area director. The thing that I would ask the working group is whether it's going to help this document to be adopted as a working group draft, which is basically saying that the document is stable enough for the working group to work on it, rather than have an individual make the right choices really quickly from version to version, and whether people are committing to work on it as opposed to watching the authors continue to type. I think that's the critical question that I would be hoping people would be thinking about as they're talking about this. Is it stable enough, and are people going to actually help or just watch? I think those are the two big things.
That's an excellent point. Right. Send text. Anna?
Yeah, Anna Brunström. So I think the document is a good starting point. So I'm for adopting. And I think also, as Spencer was hinting to, it's important to have it in the working group, because even if we say this is an abstract interface, once we build the API on top of it, they're going to have to match. So I mean, we still have choices here in terms of what we include in this minimal set and how we interpret it. And that interpretation will need to match with what comes on top of it.
Philip Teasel. I really like the document. I really like the analysis in the appendix. What I fear is that the kind of minimal set interface is limiting something built on top of that. And I think there has been some care taken to be taken to make sure that this don't happen, that this mint set doesn't really limit something like post sockets built on top or extending it. So accept that problem. I think we should really work on that and make sure that this doesn't happen. Otherwise, I'm for adopting it.
Phil,
if I come back, I mean, I would agree. It shouldn't limit the API on top. But how do you think it might limit? Because we have been. I mean, the procedure that if you read the appendix is about avoiding limitations that arise from exposing certain functionality that ties you to one specific protocol and so forth. And then, the automatable features, you can, just because we move them away to be the minimum set doesn't mean that you can't expose them. So in which way is this limiting? I hope it shouldn't be.
So where I see the biggest limitation is in having the send frame and receive stream abstraction, and I think it's hard to just fix this in something extending it. And the question is how to go about that. But I think this can be part of a discussion of the draft within the working group and not before adoption.
Okay, so I see no problem in putting straight messages over it if you want to add that. But okay.
Okay, sounds like it's something that can be worked out after adoption.
Hi, Colin Perkins. So I definitely agree that this should be adopted. Coming back to, I think, the comments Tommy was making earlier, and the questions about fallback and so on, it's not clear to me why things like fallback should be mentioned in this draft at all. Are they not a higher level policy thing? You could use this min set to build an API that didn't do any type of fallback. So I think we should maybe separate out the policy about how you fall back, how you automate things, from what is the minimal set of features that you may want to implement in any type of API.
Well, if you want to be able to fall back to TCP, you end up with that min set. If you want to be able to fall back to UDP, you end up with a different min set, and so forth. You can't separate.
So maybe it's not the min set then.
Well, with the limitation that I put on it, on saying you want to be able to fall back on TCP. If you want to do no fallback at all, it's a bigger set. Certain things go out because you need to be able to fall back to TCP.
Well, some applications need to be able to fall back to something that looks like a TCP-style byte stream. Not all applications want that.
Sure, that's fine. But then it gets bigger.
Kyle Rose. Yeah, I mean, I see this as a choice that was made in coming up with this draft was we decided that TCP was the most widely deployable transport, and so any application that wants to be most widely deployable would need TCP as a fallback. And maybe that's not true, but I think it sounds like that was the assumption that went into this.
Yes.
So, but anyway, I'm in favor of adoption, so I don't want to belabor it.
Bob Moskowitz, HG Consulting. In the security arena, sometimes we look at UDP as our fallback because you can't get anything through. And in a DDoS situation, you have to do like what DOTS has to do with singling. Maybe do a singling just fine on TCP when things are working well, and then things go in a handbasket in the network, and then your fallback is UDP, not TCP. Mm-hmm. So that's one thing that I like to comment. I find this interesting to follow. I'm new here. The other thing is that looking at this comments earlier, I remember a conversation I recently had with John Clenson, who lived the OSI fun and games. And much of the OSI work died because of complexity. And the whole thing about what TCP was about was for simplicity. So as underlying calls, this looks really interesting, but it better not be what the application sees. That you need to somehow get to a more simplistic application API model. This is really great.
Well, I think this is
the final thing
we are trying to do.
And the final thing I'd like to say is that the other area I work with in highly constrained networks and highly constrained devices, more constrained than what IETF tends to deal with, I can't afford IP and TCP. I'm just doing direct messaging like on CAN bus FD, where I only have 64 bytes for my MTU. So if I had something like this that the application would use, and then it just kind of like wrapped it up and sent it across to the gateway, which then puts everything on, boy, would that be a win in those environments. So just some other thoughts in areas as you're moving forward.
Thank you, Bob. Let's cut the line off after the two folks that are here.
Hi, Colin Perkins. Just to follow up on that a little. I agree we should aim, simplicity in an API is a good thing, but we should be realistic about what the current API is. This looks like, if you turn this into SOC options and sockets API calls, this looks like exactly what you would write for a lot of applications today.
Dmitry Pichulin, CryptoPro.
I can't hear you, I'm sorry.
Dmitry Pichulin, CryptoPro. I'm newbie here, so my question is, I see this interface look like a rock-solid synchronous interface, and application should call these functions for to get TAPS, transport services to work. So what about asynchronous interface for application? It maybe a good reason to send some callbacks what receive and send for application, and the application automatically can receive data not to call in these functions at all. Thank you.
Yeah, so this is not specifying a concrete API. It is a list of services. I'm sorry for having created the confusion by calling it API. I can see that now that people tend to look at it as an API that you're going to implement and use like that. This document, together with its predecessing document, is analyzing TCP, UDP, UDP Lite, SCTP, MPTCP, and figuring out what are the services, and then having a way of reducing some. And then, as part of the process, as part of how I decided to make it, say, well, if you want to be able to fall back to TCP, for example, then this is what you end up with. It's just that. It's just this analysis and not more. And it has the role of being able to influence API design decisions to say, if you want to add all the functionality that, for instance, this protocol offers, well, you got to do this. If you want to be able to fall back to TCP, well, you got to do this. I could have made a fallback to UDP. It would have made the document longer. It was just a decision to make it like that. And well, this is not answering your question. Answering your question, we have an implementation, for instance, that covers the MinSet and more, and it's using callbacks. So this is not about the concrete implementation. That helps.
Okay, let's close out the discussion here, and before we move on to the next thing, I'd like to get a hum of the room. Question is, should the working group adopt this document as a working group item? Yes or no? So the first is, if you're in favor of the working group adopting this item, please hum. If you're opposed to the working group adopting this item, please hum. Okay, I think I heard one person hum against, and maybe a few dozen hum in favor of. So that sounds like a rough consensus, and there was, I think, a lot of very good feedback that came in the discussion. Hopefully we've got some of that in the notes. Check the Etherpad to make sure that your comments are recorded. And I guess the next thing is, the author should resubmit a copy of the draft with the right draft string so that it becomes it's a draft tab stock.
Okay.
Thanks,
forward it to them.
Yeah. Okay. Next is the cryptography discussion. You guys are doing this in two pieces, right?
Yeah, we're going to split it up.
All right. Do you want to drive yourself?
Sure.
Well, we'll see if it works. If it works, you can do it. If it doesn't work, I'll complain about my operating system.
I don't work with that.
Yep. I wasn't talking about you. I was just.
I think you could point that.
No. This is a wireless thing.
Well, I'll just say next one.
All right. Sorry.
All right. Good morning, everyone. My name is Chris Wood. I'm from Apple. And so we're going to be talking about security stuff. I was not at the last TAPS meeting, unfortunately, in which the concern of a lack of security assessment in the APIs was brought up. And so Tommy took an action item to go and look at the landscape and see what different transport security protocols are in use today, what kind of features they provide, and how we can kind of abstract them in a TAPS-like way. So this is our discussion of that. Next slide, please. So the goal is relatively simple. We wanted to end up in a place where we have a minimum interface of sorts for any kind of transport security protocol, and waving air quotes, in which we could slide in different implementations underneath this API. And to get to that goal, we had to go out and look at everything that was in use and try to look at them not from the context or not in the lens of just a big transport security protocol, but breaking them down into their different constituent parts. So like TLS, for example, has both a handshake protocol and a record protocol in it, and try to like decouple protocols based along those lines. And so we did exactly that. We looked at a set of popular transport protocol or transport security protocols. It's not exhaustive, so I mean, if you have suggestions for things that we can include or look at, I'll be very happy to see those. Next slide, please. So, like I was saying, there's this general notion of what a transport security protocol is. It's this thing that provides some security features, and these protocols can work alongside transport protocols, like TLS is built on top of TCP and so on. But ideally, we were able to decompose these into sub or constituent parts. So for the purpose of this work, we focus specifically on what we call a handshake protocol and a record protocol, borrowing from TLS because it's common language. So a handshake protocol is just a security protocol that performs a handshake or negotiation of sorts and hopefully pops out a shared key between two endpoints. And a record protocol is something that uses that shared key to encrypt datagrams or messages back and forth between the two endpoints. Next slide, please. And so one interesting task in this particular endeavor was to look at the different components and see how they interact from an interface perspective. So for example, in TLS, you have, again, a handshake protocol and a record protocol internally. Handshake protocol will use the record protocol to encrypt both handshake messages and application data and sent over the wire. So the handshake uses the record and the record uses the transport to send the data. In more modern or newer protocols, you have, like Quick, you have the handshake, which just asks the record protocol to do encryption, and then it actually sends the data over to the transport layer, which is UDP in this case, and it also has some transport logic built into it. But regardless of what the role or relationship is between these two different or these components in a particular protocol, the features in each part are fairly common, or there are patterns that exist across all of these. So next slide, please. For example, the handshake protocol typically has a variety of very common things. It will provide a way to specify a private key, for example, to do signing operations or what have you. Authenticate the other endpoint with which you're communicating with, potentially do source address validation, and of course do the key exchange to pop out some shared secret that both parties can agree on and use for communicating. And there are some other things as well. Next slide. Record protocol will then take that shared secret, use it to encrypt packets, and send it to the other end. And so if you think of this in the context of IPsec with IKE and ESP, that's fancy. ESP just takes a key as input, basically encrypts datagrams and sends it to the other side. It's very simple. It doesn't do a whole lot. So the set of features provided by this particular module is relatively minimum, I would say. And then next slide, please. And the transport features have already been described in RFC 8095, so I won't go into the details because everyone here should be familiar with those. What we wanted to do was, by identifying these three constituent parts, again, look at the different transport security protocols that are out there and kind of overlay them on top of the protocols in existence. So, for example, if you go to the next slide, taking TLS as an example and seeing which parts are responsible for the actual handshake portion of the transport security protocol, which parts do the record stuff, and which parts actually do the TCP stuff. And of course, with the TLS as the main example, the overlay is relatively straightforward because there already exists a handshake and a record protocol internally. So none of this should be new to anyone or surprising to anyone. TLS is built on top of TCP as its reliable transport underneath. There's handshake mechanism that starts a connection, sets keys to, or gives the record protocol a key to start encrypting application data and handshake messages depending on which version of TLS you're using. And the record protocol will occasionally error out to the handshake protocol if something bad happens, like a particular record fails to be decrypted properly and authenticated. And the handshake protocol will then possibly during the negotiation process provide information up to what I'm calling this connection kind of layer, which is essentially the API to the protocol and potentially beyond to the application. Yeah, Miria.
I'm just wondering what the connection box actually is.
So most TLS implementations will not have like an API directly to the record protocol. You just have this generic TLS context in which you read or write from. So it's more of an API level thing. So perhaps I should just not have that. And you can consider basically the application, the connection, the same box because the lines in and out are the same. So, and another feature of this particular variant is that the application will typically configure the handshake protocol with, for example, cipher suites that it supports, what signature algorithms it wants to provide, and a litany of other kind of features that it wants to enable or disable for the purpose of a particular connection. So fairly straightforward. Next slide, please. And DTLS is not far off from this. Basically, it's TLS with some minor changes, particularly in the handshake step, to ensure reliability of handshake messages. Yeah, sure. Right. So from the perspective of the interface that's provided by each of these different boxes, it's basically the same. It's just internally, DTLS goes to some additional lengths to ensure that handshake messages are actually received by the other end and in the correct order. But from the perspective of the API, it's almost identical with the exception like you can have messages and datagrams arrive out of order. Yeah.
The only thing that is a little confusing here, the reliability layer doesn't make a distinction between the handshake versus the application data, because obviously like the whole purpose is to have the application data sent unreliable.
Yeah, of course.
There's also the error messages typically bubble up in many cases to the application layer.
So I'm kind of lumping that into the callback slide. Yeah, so these diagrams could very much be improved. I don't claim perfection on any of this. But yes, thank you for pointing that out. There's a distinction, as Kyle actually pointed out to me yesterday in a conversation, that reliability and orderliness is guaranteed for the handshake packets, not necessarily so for the application data, because again, that's the whole point of datagram security protocol. Next slide. So Quick is a completely different beast with respect to TLS. Most people know that it uses TLS internally to actually do the handshake protocol itself and then just pop out a shared key that it would use to encrypt all the rest of the packets with. So and I guess another interesting point is that the transport part of Quick and TLS exists on top of the actual handshake part. So in contrast with TLS, where like TCP lives below the actual TLS layer, and you have TCP mechanisms and state machine existing beneath that, Quick lives above, and as of now, kind of not exposed to the network, or not much of this. The Quick state machine is exposed to the network. So the way these boxes work together, so again, Quick will use TLS to do some negotiation, get a shared secret, and pop that out. And then once it has that shared secret, it will then shove packets into this packet protector, which is basically the record protocol, get back an encrypted stream, and then send that over its unreliable later UDP and get it to the other end. And all of the transport semantics are basically shoved into this Quick box, which we have here, and applications interface with it by using, there's no common API right now because the protocol is very much in flux, but in theory using a DTLS-like API to read and write datagrams and potentially do some configuration, which was also omitted from this particular slide. But the point here is that in contrast to TLS, wherein the handshake protocol and the record protocol are very tightly coupled, Quick decouples them for the purposes of simplifying things from a construction perspective, but it also was really nice from a kind of analysis perspective, because you could, in theory, run Quick with just a PSK that you've derived out of band. Doesn't need to be the one that's exchanged through TLS, and you'd be just fine. Next slide. So TCP crypt is another one we looked at, and it's great because it's extremely simple. Key exchange is kind of baked right into the TCP layer itself, along with the encryption. So nothing really fancy going on here. You offer up support for TCP crypt, you do a key exchange right after, and start encrypting all your TCP packets or segments. So, ta-da! I don't know. Next slide, please. Minimal T, not an IETF standard or protocol, though it was an interesting one to say the least. Again, also follows this very common pattern. If you're not familiar with the basic design, it merges and blends many different things. It's a secure transport protocol built on a assumption that there exists a directory service from which to obtain keys. So how you actually derive shared secrets and do a handshake is a little bit different from TLS. But the basic going from the application perspective, actually starting to send encrypted data over to the other end is very similar to all the other protocols. So if you wanted to speak to a particular server, you would, if you don't already have, for example, the ephemeral public key of this particular server to do a key exchange, you'd have to go to this directory service to get this public key, and you open up a tunnel to this directory service, get this information, use that to open up a tunnel to the other end of the server that you're talking about, and doing a key exchange there. And then once you have the shared secret, you just start basically sending packets back and forth over UDP with some kind of reliability delivery layer built on top of UDP to ensure that things get from end to end in any order. So again, we see the same exact patterns with respect to what the different pieces of the protocol are providing. There's, a very clear distinction, it's very clear that the tunnel-specific parts of Minimal T are doing the record protocol behaviors of our, generic transport security protocols, and then this control part of Minimal T is actually driving the handshake. That is to say, going to the directory service, interacting with that to get public keys, and then telling the tunnel or opening up a tunnel and doing a handshake to actually get the shared secrets to start encrypting data back and forth. And then there's a very distinct transport box that just exists beneath that. So we can decouple these and separate them as needed. I will say, though, that the Minimal T is also interesting in that the API for applications is not necessarily the same as TLS, where you have like this, like Tommy was saying earlier, this byte stream-like API or TCP-like API to abstract it up. Minimal T depends or exposes an RPC-like API where clients will just send RPCs over to the server and expect a response back. I'm not going to try to rationalize the use of that particular API. It was designed for a very particular purpose, but here in TAPS we're trying to maintain this TCP-like API. So, you could very well do a Minimal T-like thing without RPCs. That's not a hard and fast requirement. It's just that's something interesting to point out as a differentiating factor.
So Chris, I'd never heard of this before. Where's it used?
It's a DJB mechanism or DJB protocol, and they have some, I forget the name of the project, but they're using it within the context of this one research or funded research project. Has not seen widespread deployment.
I see. Okay.
Next, and then IKE and ESP for IPsec, again, very similar. And I would say one of the nicer of the variants in that there is a very clear distinction of the roles of every single bit of this ecosystem. You have IKE, which is a key exchange protocol used to derive secrets that ESP, which is a encapsulation protocol forward packets to send them over the wire using a specific delivery mechanism, which is just IP in this case. And so similar to TLS and other handshake protocols, you configure it a certain way, and then Ike would just shovel off all the secrets that it uses or derives over to ESP to actually handle encrypting and decrypting datagrams, and the application would just interact with it, much like it would with TLS. So on that note, yeah, you can go to the next slide. So Tommy's now going to talk about how we try to distill all of these particular features into what we believe is a good common set of interfaces that we can use to abstract away much of the protocol specifics. And on that note.
Hi, Colin Perkins. Just before you move into that, one suggested addition for the previous, which is that secure RTP is a record protocol, which is usually, I think, keyed with DTLS.
Yeah.
The issue here is that the record protocol is different in that it does partial encryption of the packets.
Yeah. So SRTP was
that's
one thing that we admitted we need to include. Yes,
Yeah.
it is kind of.
So there's that one feature which is missing from the others that you've considered. Yeah.
Yeah, certainly if there are other candidates as well, we can include them. Yes, or to the list. But yes, there are. For each of these, I think we ran into little tiny details that were not necessarily, that were very specific to that particular protocol, like SRTP being one of them with the partial encryption, minimal T providing a different flavor of API, and so on.
It's just that the API may look different with partial encryption.
Right.
Yeah. Did that get into the minutes? Minute taker. Did that get into the minutes? Thank you.
All right. Thank you, Chris. So I'll try to just go quickly through this. I want to first just present kind of what we distilled as the list of interfaces and how we group them. You can look at the full list in the draft, but the point is try to see how the shape of these transport security interfaces matches up with the shape that we've derived for the usage documents for transport, and maybe see how that would apply to things like minimal sets and APIs going forward. So next slide, please. All right, so there's a whole category of interfaces that totally fall into the configuration category. These are all generally just presumably from the application to the security layer, but you really shouldn't have to care. It's just kind of like application interconnection. And that's setting up your keys, that's setting up your algorithm preferences, doing session cache, explaining how you can get authentication delegation to do trust evaluation from the application level if that's required. So those are pretty simple. What the handshake has specifically as its interfaces are more complicated, and so here I've listed all of the relationships. So somebody, whether it's the application or the transport implicitly or the record protocol when it doesn't have a key, needs to kick off a handshake. The handshake can talk up to applications to say that I need you to validate this identity or this source address. That's a point that I want to come back to later as something that differs from a lot of the stuff I've seen in transport interfaces. The handshake can talk to the transport to send and receive. That's very simple. And it talks to its record to do the setting of the keys. Most of those could probably be completely implicit to an implementation and don't really need to be part of any kind of minimal set exposure. All right, and finally, the record is very simple. It receives keys from the handshake. It tells the handshake that things have expired, that it needs new keys. It can interact with the transport to encrypt and decrypt, and also get interactions about, do I need to migrate my keys to a different set of addresses in case there's mobility there. Again, most of these should be hidden generally, potentially with the exception of the transport mobility, because if you have a mobility interface up from the TAPS level, that may apply all the way down into the record. So next. All right, so I didn't list these out, but this is essentially the boxes that the existing usage documents, which are now going off into their nice crystallized form, have. So they have connection interfaces and data interfaces, and those are individually broken down into established, maintenance, and termination for the connection state, and sending, receiving, and errors for the data. So all of the transport protocols seem to fall cleanly into this. And so the question is, when we look at these security interfaces, do they fit into these? Do we have kind of entirely new categories that we need? And how would that change the API? And then beyond that, because I've listed in the interfaces how the security layers and the transport layers interact, how useful is it to define that layer? Or do we really only want to talk about kind of what goes up to the application? So that's a question I'd like to hear your feedback on. Next. So here's one way of overlaying some of the interfaces from security. I only did a subset of them that were interesting to give representative ideas. So certain things very clearly fall into the establishment phase. If I need to set up my identity, set my algorithms, that's very similar to setting any other option on a transport connection. You just do that from the application down into the protocol. There are other parts of establishment that ideally would be implicit to starting your transport. If you're, say, I want this connection, the transport layer can just kind of signal over to security, yeah, you got to start your handshake once I get TCP up so you can do your TLS. Hopefully that lighter gray box doesn't need to be exposed. Same goes for all of the record level things that are happening on the data path. I believe, looking at those interfaces, that those should be essentially overlapped with what we already have in the send, receive, and error cases today in the usage document and the min set. Certain things, like I mentioned before, handling the mobility of addresses and interfaces is very much a maintenance thing that you probably do need explicitly somewhere in the interface. And then the weird ones, at least they seemed odd to me looking over this, were the things like identity validation or source address validation, which are traditionally upcalls from the security layer into the application, and they can happen during establishment or they can happen later on. It's essentially a cry for help from the security layer. And at least I was looking through the usage document, I didn't see many other cries for help currently in transport.
So a clarification question on source address validation here, you really mean the lower layer has either some change in the source address or a source address that you might be doing whitelisting or blacklisting at the app layer.
Yeah. Chris,
and
can you comment?
It's like, is this guy okay, or what's the? So to verify, it's not about validating that a source address on an incoming packet is actually tied to, like, actually is where it is, right? This isn't anti-spoofing. This is a higher layer thing than that, right?
No, it is. Chris Wood, Apple. It is like the DTOS cookie mechanism.
Oh, okay. Okay.
That was the intent of it, at least.
Okay. Yeah. All right. Oh, yeah. So okay. So then it's basically cookie fail.
Yes.
What do I do? What do I do?
Exactly.
Do you cookie failed? Abort, retry, ignore. Okay.
Right.
Yeah. Okay. That's all right.
Which is kind of similar to, like,
right.
I have this trust thing. What do you want to do with it? Is it
Right.
fail?
Yeah.
Is it good?
Yeah.
Right. So it's a new it's like,
yeah,
they're question type of failures. It's not a pure error. It's not like error, I tear things down. It's like, what do you want to do with this?
Right. Okay.
So that was a new bit. That
I
was
share
the
your
one
perplexity. I share your perplexity at this. I have no idea what to do with it, but
yes. Good. Okay. So that was that. All right. Next slide. All right. So this is the last slide. I'd like to pose some questions here. So some of them are more administrative things, like, do these security interfaces, do they belong in a common main interface? Like, would it make sense to have something like the min set or a draft off of the min set include security in kind of the main interface that we would expose? Or alternatively, you do more like what a lot of APIs do today, in which you have your nice transport layer, and then presumably the application uses another layer that adds the security as an overlay to it. I think with the direction for post sockets, we would like to see those things combined so you have security implicit, but certainly one could have it as an overlay. Did you want to comment?
Bob Moskowitz. I've actually been working on this particular area for a couple of years. CSU here is in my drafts about secure session layer services in my secure session envelope. And because there's a number of drivers, like I said, I'm dealing with Mac PHYs where you don't even talk about running IP on them. Right. And I'm also dealing with environments where the network's gone totally down the tubes. So one of the things that I see here that you may want to change some of your wording because it changes semantics significantly. You're inheriting the word handshake from TLS and others. This is the control channel. Change your wording from handshake to control channel.
Sure.
Then you can start talking about the control channel that actually does more than just security. Security may protect other things you need to do in exchanges between the peers of the communication. But there are other functions which then become an inherent into the control channel besides just security. Or security protects these things that you need to do, but talk about as a control channel more off to the side than like underneath the application or however you arrange your picture, and that's one of the areas because not only am I working at this layer, I'm also dealing in 802 of the MAC layer security as well, and how we do the security control channel. I was the chair of 802.15.9 of how we do security for 802.15.4 and a few other areas like this. So I might recommend you do that change in it, and then the singling. And I'd be very interested in working with you because I've been very much looking at, this is soon, I've been working at this for quite some time, and we're not transport people per se. But we're not totally ignorant either. And some of the ways to do this in saying what services do we want to provide in this sort of thing, so that, oh gee, I can do these in these environments. I can provide these APIs. And the other thing final thing I want to say is I'm also working identity-oriented networking. We had Ideas Off on Wednesday. I'm the author of HIP, which is one of the main identity-based environments. And one of the areas I'm looking at is moving the identity discussion up into the application, not just in the network, and how that thing can apply there. Because again, you talk about identity in here, and this is one of the other areas which again we're looking at, and thus the higher layer of decoupling we can then get when we have an identity organization in this way. So here's some things to think about, and I'd be very interested and willing to talk to you about this.
Yeah, thank you very much. And I think the goals of being able to support the use cases you're talking about, in which we are dealing with more identities as endpoints and working on things which we don't have TCP/IP, that's very much what I envision for the APIs built around this to provide.
I've done the security and stuff I did IPsec, I did TIP, I did 802.11i, I did 802.1ae. I've been up and down all across on this thing, and it would be really nice to trying to
we welcome your feedback.
Together.
Hi, Brian Trammell. So if I can paraphrase the very beginning of Bob's comment, the answer to the first question is yes, embed security in the main interface.
Yes.
Right. So when you start talking about, you say you go away from handshake and go to a control channel, which I actually I like. I agree with that.
I like that too.
That seems like a good way to go. Now you've embedded into the main interface because you're sort of blurring that line between control and control, right? But I think that's a good thing. From a document standpoint, for the documents that come out of this working group, like if we take this work and do it within TAPS, which I think we should. I don't see that question up here. Were you going to ask that question?
Yes, I was going to ask that question. That's not on the slide.
I was going to ask that question.
Oh, right. Oh,
That's
sorry.
his job.
Yeah, he's the chair. Right. Okay.
You're welcome to provide input towards that question.
Can I provide input towards that question
Please,
now?
Brian.
That seems like it might be a good idea. So the issue here is that we basically kind of pointedly decided to ignore security at the beginning of the whole TAPS thing. It's like, oh, we have no idea what we're doing, and now you bring this document in, and now it looks like we do kind of know what we're doing. And I really like the framing of this document, and I think that we need to say something about it. But if we talk about embedding security in the main interface, that's not something we can do in the documents that we've already published.
Sure. Well, and I would see this as parallel.
Yeah, so it's parallel, right? So
I think
it
feeds in as another.
Right. So I think that so basically the place where it all comes together is then in item 3, which I guess I'm fine with. Okay.
Yeah. That's
good.
what I was imagining.
Actually, I could see it coming together in 2, right?
It could go
part of the
into
minimum
things
set, right?
Yeah. Okay. Yep.
You could publish a separate security abstractions document, and the minimum set could say draw some from the main one and some from the minimum.
We also love our parallel documents, so we could have the security min set just like the UDP.
Okay, so Michael's in line after Kyle. No, Kyle's sitting now. Michael's in line after Colin.
Hi, Colin Perkins. Yeah, I think these are great drafts. I think it's really good that we have this coming out. In terms of the question about main interface or not, I think we should perhaps have a discussion about what the main interface should be and whether we need lower interfaces as well. I think
I was guess referring to minset and whatever APIs like PostSockets built on top of that.
So I think for the interface to the applications, I think this should be part of that interface. Okay. But I see things like minset and this as being separate interfaces below that, because I think people building new transports will want to know what the interface to the security protocol is. So if you're building a new transport protocol, a new record layer, a new control layer for the security.
So it's like we have a pyramid of protocols up to minset transport. We have a pyramid of security protocols up to minset
and
handshake or control
overlay.
And record, and then we put them together into the stage 3.
And I think the nice bit of the work that's coming out of this is that we're digging into and separating out the APIs for the different parts and getting an idea what conceptually those APIs are. So I think keeping those separate at a certain level and then layering something above them to say this is how you build a complete system is potentially a good idea. I also had 2 questions about scope, which I think and probably hope the answer is they're out of scope. The first is this is assuming point-to-point security. You're not considering multi-party security.
Considering which?
Multi-party security, group communication.
Right. This is
yes, things like Tesla for RTP.
I mean, I think that would be interesting as a separate thing. If TAPS wanted to, once it's done with everything, look at multi-party transports and security, then great. But I don't think that's.
I think it's the right answer is that it's out of scope for this document.
Yes, it's out of scope for here for sure.
But we should perhaps be clear about that.
Okay, that's a good point.
And as soon as we finish quality of service and multicast, we'll get right on the
absolutely.
Exactly. Once all the other problems are solved, perfect.
The other thing which again I suspect is out of scope is that we're meeting in parallel with PERC. With what? The PERC working group. And what PERC is doing is multi-levels of encryption so you can have semi-trusted middle boxes as part of the transport. And again, I would assume that type of security model is out of scope for this, and we're just building the base layer of encryption. But
I could see that potentially as a composition of TAPS or posts layers that you can build security on top of security and transport on top of transport.
Yeah. I mean that's my assumption as well. But again, I
don't think
useful
that's
to ask the
directly
question.
in scope. Yeah. Great.
I think that'd be a good test of the abstract APIs if you can do things like that, but only if you understood what you were trying to do. This is the first I've heard of PERC. So question for you authors is, are you bringing this to contribute as a working group document? Right? Would you like this to become a working group document?
Yes. I think Miria had brought up the question earlier of the charter having a couple words about like, we're not getting the details of security. So I'm not sure if that requires a specific text change there, but yes, I think we would like this to be a working group document as part of the milestone 2 phase.
If I recall the charter correctly, that our restriction is that we aren't to develop any security protocols. I don't think that we're restricted from talking about what exists, but here comes an area director.
It's a little vague.
Spencer Dawkins, responsible area director. I'm remembering roughly what Aaron is remembering with the additional thing that basically do people in TAPS know enough about security to work, to focus on that first. And since this seems to be a sea change in the ability of TAPS to focus on security, I would be thrilled if it turned out to be necessary to do a charter change. I would be thrilled to do that.
Okay, so let's.
'Cause I think that will make it easier for
Brian has
documents to make it through the ISG.
All right, Brian.
Can you quote the charter?
Yeah, I was going to.
Spencer, one question for me. If we just do a survey of this security protocol, do you still think the charter change is required? I mean,
Let's go to the charter. Hi, Brian Trammell. TAPS is not chartered to perform detailed security analysis of the security aspects of transport protocols. Full stop. While security can be a transport service, TAPS is being chartered almost simultaneously with TCP Inc., which is developing the TCP extensions to provide unauthenticated encryption and integrity protection of TCP streams. And TAPS will work with TCP Inc. to ensure that TAPS will be able to accommodate the protocol extensions that TCP Inc. provides. So we have an independent clause versus dependent clause interpretation problem. Any Second Amendment fans in the room? If you read the first sentence in of its own, then very, very clearly this work is completely out of scope and it's not on charter. If you read the whole paragraph, then it's completely on charter.
Yes.
So
it's literally bringing TCP Inc.'s interface into the
exactly.
So what I want, to be very concrete and pragmatic, and the TCP Inc. chair is standing behind you, but what I want is that when we submit these drafts to the IESG, is for the security area directors not to put a hold on them and say, you guys said you weren't going to do this. And so I think that we've, just in Chair's opinion, I think that we've got a critical mass of people who've got energy and expertise who want to work on this. We're not plowing any new ground. It seems to me like it's low risk. But I think that there's maybe a little socialization task that I would like to ask our area directors to do to just get some confirmation on it. And I'm willing to proceed on an optimistic path, assuming that we're all working in a spirit of goodwill here and trying to do good things. Kyle.
So Kyle Rose, speaking as TCP Inc. Working Group Chair, it sounds like we probably do need to recharter, because my impression from how this work is involved is that we do not want to limit this to TCP Inc. So I think that's pretty clear. Well, I'll look at it and see what needs to be changed. But so speaking as not TCP Inc. Working Group Chair, I think that I think that there's increased scope for security, I think, and that there are people basically. I'm not entirely sure what I'm trying to say, but we need to include security as a first class element of TAPS, and I don't know that it makes sense to. I think we sort of presumed, and I wasn't around during the working group chartering, but I think it sounds like we presumed that, we're just going to make use of this TCP Inc. thing, but now since it's clear that we want to abstract and use all sorts of security protocols, that we should go down that route. I would not be in favor of a charter change that involved, say, us being able to design our own record protocol. Let's not do that.
Right. Nope. Right. And I don't think that's anybody's
right. And the charter should specifically say we're not designing security protocols. We're not.
I don't think we want
to not doing
remove
crypto
that
work.
text from the charter.
We're just talking about how they relate.
Yeah. So Michael's been waiting, then Spencer, then Bob. And then I'm going to close the line. And please try to, Miri, I guess. Let's keep comments brief so we can get out of the politics and get back into the technical piece. Michael.
Okay, I'll speak as someone who was there when the charter was made, and that was much about getting the whole thing off the ground and avoiding complications with not having enough security expertise, TCP Inc. happening in parallel, we can't get this right, and so on and so on. My proposal would be to just remove this paragraph and be done with it. But I mean, okay, this is specific, but I don't see anything, like any reason to keep this paragraph at this point.
I think this was a paragraph that was put in to keep us in what was considered to be a box where we would not do any unintentional harm. And so, you're not the person who I'm concerned about.
Sure. So that was really just to decouple it from security so we can work independently. So at this point, I think this is useful work, and we should actually get a few people into the boat. So we just have to make sure we're kind of aligned here.
Yeah, Spencer Dawkins again. So I would say that the combination of where the working group is now compared to where you were at charter time. And nothing has happened in the past 3 years to make us think that security matters less. So the combination of those two things say basically that doing this work is the right thing to do. And I think TAPS is probably still the right place to do it. And that like I say, I'm happy to take a charter update forward that spells that out if the working group thinks that that's necessary in order for you to be able to do the work. But yeah, so like I say, I think, it's do the right thing, but I think it's becoming more obvious what the right thing is.
Okay. Yep. I think we'll take a close look at the charter text and see if we need to propose
Bob
changes.
Moskowitz, just kind of echoing everybody else, that the work that I've been doing on this, I see a clear delineation which can be achieved and things which can be done to make it clear what are the interfaces such that a security service can then work well with whatever the transports du jour are. So what TAPS would be doing thus to better enable security, and then how then the security works then proceeds along those lines, I think would be a win for everybody. And we can do that delineation, separation, and we can benefit significantly from it.
Architecture. It's a great idea. Okay, so let's conclude this discussion with a hum. The question is, should the working group adopt this work? And if we agree to do that, then there's an implication that we'll go and we'll make sure that the charter is adjusted accordingly and make and publicize this to other folks who would be interested. Chris, do you have something to say?
Yeah, there are two documents. Is the question about both of them or just?
To me, this is still a little bit of an undifferentiated mass in terms of like what the I mean, I guess this is the problem with asking a question. That I think there's the first order question, which is, should we add security transport functions to the abstract API effort that we're trying to do in TAPS?
So I think your question is actually, should we change the charter and add this to the charter, right?
Okay, I mean, there seems to be diversity of opinion whether the charter needs to be changed or not. Let's everybody propose something. Go ahead.
Sorry, Kyle Rose. So I might propose removing the last paragraph and just changing the.
Were you talking about the charter? Paragraph
yes.
of what?
Sorry, yes, the last paragraph of the charter, which Brian read out, and changing the third bullet point right above it to extension, modification, or creation of transport or security protocols. That keeps us from designing our own record protocols and whatnot.
You know what? But I am not prepared to have a charter editing discussion in real time.
It's just a proposal. We can talk about it on the list.
Okay. All right. Let me back off. Let's just get a hum of whether people think the security work is interesting. We should continue to have this conversation. Yes or no? All in favor of hum, yes. Anybody thinks we just shouldn't do this? It's a bad idea? Okay, so there's a clear consensus for that. The interested parties will get together and we'll come up with a concrete proposal on how to move forward. This doesn't work in group concept. Thank you very much for putting this together. Bob, thank you for stepping forward and showing an interest. This is terrific. Okay, so, what happened here? Just quit flux. Okay, on to number 3. I think we're running a little bit behind, but not irrecoverably. Are you keeping an eye on the clock?
Yeah,
a little bit.
Pretty behind, actually.
We're pretty behind. Okay, so we have an hour and we end at 12, right? We have 50 minutes, and we have 2 presentations and a discussion. So let's try to keep each thing to 15 minutes. Do you think you can get through your stuff in 15 minutes, Phil?
Makes the discussion a little short, but we'll try.
We'll try. Okay, we'll take the temperature 15 minutes and see if we want to stop or go on. How's that? If you want to...
Sure. I think the battery is empty.
Oh, you think that's it? Okay. Oh, it's empty. Yeah, next slide.
So today I will talk about 3 drafts. This is a little bit, and all are in the area of automatic transport selection or transport option selection. This is joint work with my colleague Teresa, who's there on Meet Gecko, and yeah. So next slide, please. Everything I want to talk is about inputs to transport option selection. So if you want to automate transport option selection, what do you need as inputs? And we came a little bit from the multi-pass or deciding which multiple interfaces and paths to use. Therefore, this might be a little bit pointed towards this direction. So first we need path characteristics to decide which path to use. We might need the needs of the application, so optimize for bandwidth, latency, cost, traffic characteristic, tolerance towards packet, data and connection loss. And we need a way to decide how to compose a transport protocol stack, and probably to debate how to include on-path elements. And next slide, please. The first draft, the socket intents draft, goes into the application needs discussion, while the second draft, next slide, please, goes into the discussion on how to compose a transport protocol stack. Next slide, please. So what are socket intents? So with socket intents, applications might express their communication preferences in order to take advantage of the available transport repository. So socket intents are hints for transport option selection and are not meant as strict rules, but just little intuitive, generic, protocol independent hints given from the application on what they're going to do with the upcoming communication. And they should be matched in a best effort way. So if this operating system can match them, it should match them. If it can't, it will provide the best service it has. Next slide, please. And so just given, we have a lot of examples and detailed description of the examples within the drafts. So I will keep that short. Next slide, please. So what an application programmer can express with socket intents is rough things like the traffic category. Are we going to do a bulk transfer? Are we going to send a little control messages? Are we doing streaming? And the various categories of this can be, for example, the object size I expect to send or receive for a communication channel, the duration of the existence of the communication channel, yeah, other constraints or cost preferences, whether the application thinks this should be, this communication should take place over an expensive link or not. Next slide, please. And so we see all this information as inputs to transport option selection within, for example, the TAPS system. Next slide, please. So we think socket intents can be used on a per flow or per association, per stream or per object level. And we really tried this out on a per stream and per object level and found we have good results with that. And socket intents are presumed to be API independent. So we have a BSD socket based implementation that also supports connection caching, and we've done some thinking about whether this could be included into post sockets, and we think yes, it can. Next slide, please. So having the information from the application, the next question is, and having the path properties which are more or less measurable, the next question is, when we can decide what the path is or what the endpoints are, how to decide to compose a protocol stack. And for composing this, we have to compare them to find an order on which one to use. And therefore, the second draft talks about communication unit granularity and about how to do this decision making, how to reason about protocol stacks. Next slide, please. The basic idea is to decompose a protocol stack into 2 orthogonal things. So first we look about which communication units are operated on, and second, which mechanisms operate on this communication units for multipass. And this perspective allows us to compare mechanisms like distributing requests of an application, so HTTP requests. We have 100 objects to fetch for a website, how to distribute them among 2 links, so just having 2, for example, TCP sessions running HTTP2 and distribute the objects that way, or to use just one HTTP session and use MPTCP over that. And so we can compare this kind of approaches against each other and reason with what is the right approach. Next slide, please. So what are the communication units we're thinking? And the point is protocols really align badly with the communication units, with the semantic communications unit of an application. So we see the communications units as object or message. So for example, an HTTP request, a stream, like a stream in Quick or SCTP, or a TCP connection for XMPP, an association, or we call it flow, which bundles some streams, and an association set or flow set that bundles streams, bundles associations that belong together. Depending on the protocol stack and the application use, this communication unit hierarchy elements can just merge as they like, and mechanisms can therefore not be sharply assigned to one of these areas if they merge. Next slide, please. So the next thing we talked about is how these mechanisms work, what mechanisms work on these communication units. And we see we have as a mechanism destination selection. So for example, DNS resolution and finding out which endpoint to talk to. We have path selection. So deciding over which path to talk to the destination. And depending on which kind of communication unit you're applying this might look quite interesting. See draft for details. We have chunking, so how to, from an application level, split stuff. And this can be just naturally like objects of a website already split, or can be split by a lower layer like TCP segmenting. And scheduling, which can also seen as the per object or per chunk path selection. This deciding how to distribute the stuff. And we see with these mechanisms together with the communication units, now transport stack instance selection means just composing a system from protocol stacks instances that implement these mechanisms to come through a whole system. This is a fairly abstract and complex view, but I think it's the way you have to go if you want to reason about how to automatically compose stacks in a system. So we have a prototype for BSD sockets, I already told you. This is a wrapper for BSD sockets. We have 3 API variants, and we have a working code release on GitHub, which has done just a few days ago with all features we mentioned here. Yeah. So if you have interest, have a look. The prototype basically is composed of a socket library with our API, and on the other hand, instrument that has a policy with just still being a piece of code. I think this is a discussion we will have later on how to really represent a policy. So I think just having a piece of code is not the final answer for what is a policy in an automatic transport option selection. Finally, I want to conclude with the lessons learned from this. So first, name resolution is quite separate from socket handling. So doing this within the BSD socket API is quite painful. And the other one is file descriptors, for me, are considered harmful because the semantic of file operations really do not match the kind of thing you have to do for network communication. And the semantic of file descriptors much change depending on what kind of transport protocol you use. So a TCP socket behaves quite differently than a UDP socket for some system calls. And therefore, I would warn everyone who's doing this system, TAPS system to sticking too much with the BSD socket API. It will be a pain. So that's it for the talk, and I would like to raise a bunch of questions. So first, how to proceed with the socket intents work. We now have a draft on that, and the question is the working group interested that I, or perhaps the working group, continue on this work, and how it will relate to other drafts, especially the one named. The second bunch of questions for the BSD sockets draft is proceed with this document. So we still consider this as background work for the socket intents draft, and therefore I will publish most of its contents in my PhD thesis and the tech report anyway. So if we just need something to cite, there's no use to work on this as a IETF draft further. And the third one is about the communication units granularity thing. What impact does it have on the terminology? And I think we can't discuss this today. Challenges on transport option selection, but this is, I think, interesting for further discussion. So,
give one more.
Okay. We'll talk about
get back to that. Okay. So,
Tommy, Polly, yeah, thank you for bringing this. This is a very good topic. I think a lot of the details we should talk about in the policy discussion at the end, because I think that really is kind of all about this. As far as the documents, I can imagine if we want essentially a policy management document to kind of go into those details, having something like this would be a very good starting point for doing that. I could imagine maybe having just kind of one document around that. You brought up the relationship with the TAPS guidelines document I had done. One question that I've been wondering is how to proceed with that, or kind of split that out into the various places where it should be. I think that also ties in well with the Happy Eyeballs document. So as a proposal, I could imagine that we could have, grow the Happy Eyeballs document, because right now it talks about, how you do the protocol stack racing. I think generalizing that to also potentially include some of the work that I mentioned with the, there's endpoint racing, there's protocol stack racing, there's other types of how you build your connection. I think that could be its own document of just the details of that establishment, which gets into some of the points you brought up in your documents. But then there's also the separate thing of how do we express the policy, and that's what's driving this racing tree. So maybe we end up with two there. But I think this content definitely needs to be brought in some form, although we may want to kind of chop up all of the documents and reassemble them into a Frankenstein draft. So.
Yeah, Anna Brunström. So I just want to say I fully agree with Tommy. It's great to see these drafts here, and I think it's a bigger question how to then fit the pieces. We have a number of systems doing policy, and it's very nice to see that they are quite similar. I mean, the flow is maybe different, but the general structure is still quite. There is a lot of commonality, I think, between the different systems. So I think it's possible to merge into a number of documents that describe these different features that the TAPS system would need.
So my view is that, the third phase, the third milestone for the working group was really about experimentation. It's like we've come up with a common language. Let's go build some stuff, see what works, see what we can learn out of it. If it turns out that there's rapid agreement and convergence towards certain common elements, like the socket intents as a language for as an input to a policy engine, or maybe different policy engines, that seems desirable. I think in terms of the working group's goals, if all we do is come out with an RFC that is a compendium of different approaches to implementing TAPS, that is consistent with what the charter says. I think that actually we're making better progress than that, and we can do better than that. And so I kind of feel like it's a matter of the folks who are doing these implementation projects is how you want to work together. Let's try to find a way to collaborate and and build on the areas where there's some consensus. But I would like to see some description of the mechanisms and the lessons learned in the third milestone documentation. I think that's we don't. I think that we want to document that aspect of the IETF work. I'm sorry, it's not a hard answer for what to do about your document, but I think that people are interested in the work and like it, and so I hope that you'll continue to participate, and maybe we'll find a way to fold these things in together.
Okay.
Okay, thank you. And you hit your time mark, so thanks, Philip. Okay, next is Anna. So do you think, Anna, you can do yours in 15 minutes?
Yes.
Okay.
I think so. Mine is actually not that long. So.
Okay.
Okay, so this is an update on the Happy Eyeballs draft for transport selection, and it's joint work with a number of colleagues in the NEAT project. So next slide. So this relates to the third work item of TAPS, so to how to select and engage an appropriate protocol and how to discover which protocols are available for the selected service. So this, of course, calls for some form of Happy Eyeballs mechanism for these transport selections. So we want to try multiple protocols in parallel here, so that to enhance performance, but of course in some intelligent way. So that's the idea of the Happy Eyeballs mechanism. Next slide. And we already, of course, have Happy Eyeballs mechanism in RFC 6555 for IPv4, IPv6. So this, in some sense, generalizes that problem to select the complete transport stack. And it relates to what Philip was saying, because the idea here, of course, is with TAPS also to be able to then dynamically use input both on the application requirements and our knowledge about the network at this particular point and the configured policies. Yep, next slide. So we've had the draft on this. Naeem presented it at the last IETF. This is a summary of what we have updated. So we got feedback from a number of people, so thanks for that. So we improved the wording related to RFC 6555, which was not fully accurate. We clarified that the draft applies to connection-oriented transport or transports that have some notion of connectedness. I thought we had clarified that one transport connection, only one transport connection is returned to the application, and the other connection attempts are used to populate the cache, because we're trying multiple connections in parallel and we want to learn from them. Actually, when I double-checked to see if there was something else I should add to this slide, I realized that that sentence had fallen out somewhere between the different authors, so that will be there in the next time. We had some questions about the cache lifetimes and things like that, so we for now have indicated this to be system dependent. And this will come back in the discussion points that I brought for the draft. We changed the example to use IPv6, and we fixed some other clarifications and details in the text that were pointed out in the reviews. So next slide. So then to go back to the more architecture and maybe the more important and the interesting things to discuss in this context. So in our draft, the framework we have for the Happy Eyeballs, the general framework is to have the application, you have the TAPS API, and then we also have this policy management module that is responsible for indicating what the correct transport candidates are at a given time, and then we have the transport probing part. You can take the next, hit it once. So the draft focuses here really on just the transport probing part, and it has some requirements on the policy management for what it provides, but it doesn't give the details of that component. Next slide. So in the draft, what we require from the policy management is that this is the piece that creates a list of candidate transport solutions, and they also give you some order of priority. And in general, this, of course, can be created in many different ways. You may have some pre-configured choices, or you could have a very complex policy system. But the idea, of course, with TAPS is that you should have some use of the application requirements, use the available information about the network and your configured policies. But the only thing that we specify in the document here is that we require the use of cached information so that you don't try the same things over and over and put unnecessary load on the network. And if you don't have policies that specify otherwise, you should comply with the guidelines in RFC 6555. So other than that, we don't really specify the policy management. Of course, in the implementation of this in NEAT, we have a complete policy system that uses this information from the application and from the network and some notations and rules for how to apply the policies and derive the candidate solutions, but that's not covered in the document. Next slide. So the transport probing component, that is the part that initiates the different connection attempts for the candidate solutions that have been provided by the policy management. And the requirements that we put there is that they should be initiated in priority order based on the information from the policy management. And the difference in priority then translates to a delay in the raising of the transport solutions. And the first connection is established and returned to the application. We also have some requirement that, as I said, on the use of caching. So the transport probing component should cache the outcome of the connection attempts back to the policy management and allowing all the connection that has been initiated to complete. So those are basically the only requirements that the document set. Okay, next slide. So I think what's interesting to discuss in this context, and which also ties back to the greater policy discussion, is what the interface should be between these happy eyeballs algorithm, the policy management. Do we separate them? Do we describe just some, as we have done, some requirements, or how should we, more in general, maybe split up the TAPS system and have the different interfaces between the pieces? Do we need some form of architecture document so that we, when we all talk about the policy management component, we have different implementations of that? Do we talk about the same thing? The other issue related to the draft itself is how much detail should you have on the happy eyeballs component. So many of the questions that we got back on the drafts that we submitted was on some of like the parameterization. So what should the cache lifetime be? So is that something that you should have guidelines on, or should that be left out as a implementation detail and be fully system dependent? Similarly, the time between the connection attempts should be like, regulate what the delays should be and so on. And similarly, should we have some rules in terms of how the candidate list is generated, how many different transport candidates you try in each, you're allowed to try, and so on. So those were the general questions that I thought would be interesting to discuss. Okay.
Spencer Dawkins is a nosy individual. So since you mentioned the cache lifetime, I don't know whether this is more on your first major bullet about architecture or your second major bullet about happy eyeballs implementation, but it seems like there's also an interaction there with mobility, so that so the answer, the happiest answer that you could come up with might change as a result of mobility onto a different network path with different characteristics. So just having that, I think this is a great conversation to have, and I think that's something that should probably be on the list.
Yeah, that's a good point. And I mean, you could certainly have also the cache being flushed because of external events like something moving. And
Tommy Pauly. So first, yeah, I think the model that you're going with is like 100% right. I think it's a very nice basis for this. Just a couple things. So as I mentioned before, I think it'd be good to try to bring in some of the other types of racing other than the protocol, just the transport protocol stack racing. Talk about the derived endpoint racing as saying happy eyeballs is happening here. Yep. And if you're dealing with higher level endpoints, like we have like Bonjour services going to hosts, include those.
Yeah, you have the first step is not really there.
Exactly,
like
right.
2 steps.
Right. So kind of include more of the steps. To the first question, I think that it would be cleaner to leave them separate because our policy discussion, I imagine, will evolve and grow and that can be somewhat independent from how we actually do this. So it's essentially, let's say, it takes input from this other policy management system, and then we can define them separately as long as. So I think, yeah, we should describe what the interface that the Happy Eyeballs algorithms need as an input, similar to how the transport protocols in their interface describe what they need as options to configure them. Right. For the second,
just to comment on that, I think you could describe that on different levels also, right? Because it depends on if you see that these two components in the end should be separate and able to interoperate, or if it's a logical separation so that we know what the interface is. So we need transport candidates, we need some priority, right? That's like on a very high level what you need. If you needed independent components to interoperate, then you would need to specify exactly how that should be represented, and that's maybe not necessary if, I'm not sure if that is necessary, because you could implement that interface in different ways once you go to implement your policy and Happy Eyeballs racing, which would typically be on the same system.
Right.
So, but yes.
Yeah. So we should get into those details. Yeah. For the second point, I would actually like to point to the fact that in V6 Ops, David Scalanti and we have a Happy Eyeballs version 2 update draft. So there's actually going to be kind of like a BIS to Happy Eyeballs. So we should reference that, but B, we could kind of follow the style that we're doing there, in which you define, there is a delay or there's a lifetime parameter that should or must be configurable on that system. And a recommended value is something like this. That's what we're doing there, of saying, here's how one sane way of calculating these values, but for your system, you could customize it.
Yeah, so I think, that's certainly a reasonable approach. Setting the default may be a bit more difficult here, because the cached values could be, the problems could be on different levels, right? But yeah.
Hi, Colin Perkins. So all the comments you're making about connection probing and candidate transports and so on, this sounds like you are describing the ICE algorithm. And stun and turn and all of those protocols. And I really think you need to look at what's happening in that space and reference it and bring it into this framework, because it's doing the same sort of thing for connectionless protocols.
Yeah, that is true. This is looking, it has many connections to that. Yeah.
Thank you, Anna.
Okay.
Ooh, it just worked. But right now.
Aaron asked me to frame this discussion. Hi, I'm Brian Trammell. So I only have one slide about policy. No, this is it. So there are a couple of things that I've seen. Are you already coming up to the mic, Colin? Oh, no. Okay, good.
I disagree with the shade of white.
I've noticed a few things happening, and like a lot of the work that we're doing in TAPS right now seems to be converging very nicely. And one of the decisions that we seem to have converged very nicely on is to pointedly ignore the details of policy, because that's where all of the fun, hard stuff is. And I really like that the conclusion of the last discussion was, okay, now we need to actually start getting into details. And I think we do need to start getting into details. And each of the areas of detail that we can get into is kind of dominated by, it goes back to MinSet, right? It's which bits of the abstract interface to this component of a TAPS system are parts of the, will be bubbled up to the higher API, and which of these are policies. And it turns out that in every case, it could be all of them or all of them. So I want to actually raise a different problem and say it's actually worse than that. So there's a set of parameters, of capabilities, of policies, of, all of these terms are kind of overlapping here. But they're all kind of initially based on the system capabilities, right? You can't, in TAPS, you can't raise transport protocols you don't have implementations of. It's very simple, right? You cannot raise IP protocols that you don't have implementations of or where you don't have a connection. So there's actually kind of a hard floor on where your policies can be. And on top of that, you can layer the capabilities of the application, right? Like, so I think one of the problems that we've had in doing API design for the future of transport is we either say, okay, well, it has to fit in BSD because nobody else is going to implement applications to it otherwise, or they say, oh, well, we need one API to rule them all. And I think those are both mistakes. I think we actually need different APIs for different interaction patterns. And therefore, into this sort of cascade of policies comes the API that the application was written to. This is easier to deal with because you can always put shim layers in to put any API on top of any other thing, but some of the efficiencies are really terrible. There's also application policies. There's developer preferences and constraints. A lot of what we see with sort of driving forward encryption now is actually kind of application policies at this level. Is browsers essentially saying, you know, this cipher suite with this handshaking protocol or go away. And the certificate needs to have these properties or go away. And then you have user policies. You have things that the user actually wants, right? So these would be preferences and constraints. These would be things like, you know, I like multipath and I like things that go fast, but I also have a horrendous data cap, so please don't use my cellular to accelerate Wi-Fi. You can do that on Apple devices now. What you can't do quite yet is say, my roaming schedule is such that I pay low enough rate in Germany and in the Czech Republic that I'd like to boost it here, but not in the Western US, but maybe in parts of the Eastern US because I know that there's a, right? So like these policies can actually get arbitrarily complicated. One thing that we pointedly ignore in the IETF when we can get away with it is the enterprise environment. And a lot of enterprises have organization policies. And actually, they would like to see it like this, right? So organization policies are first and then the user policies are second. And there's another viewpoint, which is that just kind of goes away because, well, the user is first and we're going to pointedly ignore the organization policies. But there's another thing that kind of cascades in here. So I think when we start having this conversation, there's all of the dimensions that we're talking about which variables need to have knobs on them, and do those need to be configured by the application developer, do they need to be configured by the user, do they need to be somehow bubbled up through the API, and we need to have sort of detailed conversations on each of them. And we also need to have detailed conversations about how we're going to implement this stack. I'm going to start with a really terrible idea in the hope that people will come up to the microphone and give me better ideas. These cascade. So you have system capabilities and application capabilities and policies and user policies and organization policies. And we have a language for taking properties of things and attaching them to elements in a system in a way that they cascade. Are there any web developers in the room? Please leave now. I think we should actually configure the TAP system using CSS. And I make this point for two reasons. One, it's not as bad an idea as it sounds like in the first time. I really want people to come up and tell me that it's a terrible idea and that we're not going to do it. But it also illustrates how hard this problem is. Because debugging CSS is maybe the great unsolved problem of the 21st century. And we've kind of decided that we're taking it on. So with that, I'd like to open the floor. Please tell me I'm wrong. Oh, that's depressing.
This is easy then. You're wrong.
You're wrong, but you may not be insane, Gory Fairhurst. Okay. Yes, but also what Colin said, yes. And maybe also yes to some other things. There's multiple blobs in here that do quite different things. So there's stuff like to do with what your provider's offering. and all the interfaces and capabilities you have of your network. There's transports you're trying to figure in here, and there's some other user policy, which if you live in an organization isn't your policy, it's their policy. So there's multiple building blocks here, and I think we don't actually talk about these together. Maybe we should. Maybe we should kind of write some documents in this space that bring these things in here. Did some stuff in the hackathon, which might be cool to talk about some other time.
Yep.
But I like the idea, but I think maybe we don't understand the blobs quite yet. And their interaction is complicated, so we need to see them all at the same time.
So what I would like to see, what I wanted to draw, but it was too hard, was the verticals here, right? So these are the horizontals. These are the layers of how things cascade. And the verticals are the different bits of which kind of policy for which part of a running TAP system you have. And like, I pretty much know what fits in this application capabilities box. Sorry, you can't see me pointing. What fits in that box? I have a little bit of an idea about what fits in that box, and then like how you bind things to these higher boxes gets really fuzzy. So I think actually trying to draw this out as a matrix, I mean, I tried to draw it as a matrix. It's hard. I think if we actually say, okay, well, let's start on this as a thing that we're going to try and deliver, and maybe it turns into a document that comes out of the group. Maybe it just is. We get smarter while we do it, and then we throw it on the ground because it's terrifying. You know, I think that the next step is to put the verticals in here and actually think about that. What I have heard, what made me happy is I have heard that pretty much every every presentation today that had some sort of policy angle actually talked about what's in their vertical box, right? Like in detail. I think we need to tease it out and classify it a little bit.
So this isn't part of the internet architecture, but I know my iPhone does all these things, right? It happens, right? Somebody's doing this,
right? Yes.
Hopefully he's going to get up to the microphone and tell us how it happens.
I don't know who that guy is.
No pressure.
No pressure.
I wasn't talking about you, Gory.
A very quick jump in on that. It'd be really nice to know how it happens, because from playing with this stuff, you really want to know what is happening as well as it happens magically.
Yeah, that's because you want to have your hands on the knobs.
I want to know the knobs are doing the right thing so I can design more things for them. It's an engineering problem, yeah.
Yeah.
So there's another, I mean, there's another problem here is that maybe you have user policies in CSS, and maybe you have user policies in a UI, and maybe you just have a user policy thing that you load and you don't think about it. I mean, like there are different, we can build both Emacs and VI. We have the technology.
Heresy.
Disagree with that, Colin.
Colin Perkins. So I think we need to be careful to avoid the boiling the ocean problem.
Yes. That's why I think that's why we've pointedly avoided this conversation, and now we've run out of stuff to do. So.
Clearly, all the rest is just a matter of engineering. But I mean, there are pieces of this I think we can make a very good stab at.
Mm-hmm. Which bits?
I mean, the lower level bits.
Okay.
And I think we're engineers. We can make the engineering choices about, well, here are the knobs to adjust these policy things at these low levels. How much of the higher level stuff should be in scope for this group, and how much of it should be things which are configured as an operating system choice or something like that? I don't know.
So I agree that the higher up this stack you go, the farther away from our scope we get. But at the same time, since these stack on top of each other, the choices that we make down here define the set of possible languages up at the top level. And we need to make sure that if we make any constraints on that we're doing it with eyes open.
Yes, I agree. The perfect is the enemy of the good, and we can do a lot of things without getting bogged down.
I'm not saying bogged down. I'm saying consider.
Yeah, sure.
Hello, Tommy. I didn't get to say you're wrong yet, so you're wrong. No,
but am I really?
In the details, we're all wrong, but in the high level, we're all right. So yes, I agree that not all of this needs to be specified in TAPS, but I think all of it needs to be acknowledged by TAPS. And we need to define kind of the shape of that. So the main point in which I think you're wrong is actually the ordering of these. Thank you. That was useful. Can we go? I want to put the application boxes on the top. So while Brian's editing that,
wait, hold
sure.
on. This?
I was. Well, what does top mean? Yeah, sure.
Okay.
But they're at one end.
It's getting
Yes,
existential
they
now.
are at one far end. The point of that. Okay, let's bring it back. Okay, so I think the application capabilities and system capabilities likely can collapse into each other and hopefully aren't too interesting. Because essentially it's like if I try to load protocol SCTP, I don't have it, it's just not going to work.
Right.
The race will fail, who cares?
Life is good.
I think the application policies is the main area that TAPS needs to figure out. I think that's built up a lot of what Philip was talking about, of intents. I think we should break that into, because you have them already, prefs and constraints. So there's intents which go towards designing my socket options and stuff like that. I think we need to work on that list, and that will be a good piece of work to do, but it's not quite as tied into all of the other constraints. On the constraint side, so I guess the proposal there would be like, maybe is that part of the same CSS as the other layers?
So you're using the terminology.
No. So at least, so talking about our implementation, right? So Gori, I'll give you your details. Essentially, we do it as like there's like an oracle when you're creating your connection, so that application policies are different than user constraints and enterprise constraints and other things. Application policies and constraints are things that are the preferences that you kind of feed into this oracle. Like, I'm the application. Here are the things I want to do. Tell me what I can do. I do think that the user constraints and the organizational constraints should be the same language. Those are some version of it. Internally, they fold into the same language for us. They are configured by different places. Your enterprise, for example, can push you an XML file right now that describes which applications are allowed to use cellular on roaming or not. And that gets overlaid with the user preferences of do they want that application to use cellular or not, and then everyone's happy there. So that's an area that exists that I believe totally fills out the CSS. I don't think we need to get too into the weeds of how that's done, because that's going to end up being system specific. But I think what we should end up defining is that these are parameters that are fed into some type of oracle that a TAP system must be able to consult to give its application constraints to, and receive back an answer of, okay, I chose this subset of the things you wanted, or here are the options you now have based on all of it.
I'm going to just
way more sane than what I did.
Make an observation about time, that we're under 10 minutes left, so I encourage people to be brief.
Spencer Dawkins, I'll drop one of my questions. It sounded deep for the other ones, and so this one, speaking as an AD, you were talking about, all these things being kind of at different layers and maybe with different people responsible for the, for those technology, for the decision points and stuff like that. I just observe, do the right thing. We're supposed to be able to work across areas in the IETF. And if we had to go all the way to W3C, to work on some of this stuff, we're supposed to be able to do that with, in cooperation with them. And that's where the CSS experts are.
Fair point.
Jahed from the floor, as an individual. I think I can thank Tommy for reading my mind. So let me see if I can add to something. This layer that you are showing, it could actually collapse, because somehow the system capabilities says what kind of application capabilities you can have, and and then you can have application policies that actually defines what kind of organization policies and user policies you could have. So they can collapse. But there are some other things like I heard like somebody say like now my device is doing it. Like if we have a choice between Wi-Fi and 3G radio, you tend to prefer Wi-Fi because it's supposed to be free and stuff like that. But things are happening in the other side as well. Like you can actually, the network or the operators, they can actually send a policy, say like, okay, you have data bucket. If you use this application, I'm not going to cut your data and stuff like that. So that also could be one thing that TAPS might want to listen to, and because that actually decides like how you're going to do your selections. Maybe in one network you select, okay, this works, TCP works. Another network, well, QUIC works. So that actually affects what TAPS gonna do. So my thinking is like all the policies decisions. I think we need to think a bit more. I think a bit more like robust way of doing it, so that we can collapse and come to a like really minimalistic policy thinking. Otherwise, and we also need to think about like how TAPS will be used, where TAPS will be used, and the underlying network as well. Yeah. Thank you.
So
briefly, please, Phil.
You asked us to say that you're wrong. You're wrong. I guess it's that you have two kinds of that kind of stack. So first you have the stack of capabilities of what can be done, and that's very below. Afterwards you have the policies, and this is what I consider policy more or less. Once you have the set of stuff that can be done from a technical standpoint, you want to filter out what shouldn't be done from a policy standpoint. So for example, I don't want that application on cellular. And last, you have the point of ordering it in a way from what is preferred. I think there this CSS really matches well the idea of how to do that. And afterwards, after we have this ordering, then you're back to happy eyeballs on trying out what of the order you have. And this might be really awesome. This might end up in using always the last thing on the stack that's least desirable. But yeah.
Cool. Thanks.
Shweta, Cisco. I don't have an opinion about the way the policy is expressed, but just to boil the ocean further, I don't know if it is implicit, but does system capabilities also express network capabilities? Because
yeah, I was just looking at the slide and I realized no, it doesn't. It should.
Yeah.
Right. That's like there's a missing, like the whole point of this entire thing is down here. You can't see it. It's very light gray. Yeah.
Okay.
Oops. Yes.
So I think with the multi-provisioning domain work and and path selection that we want to do, I think that should come in here.
Yep.
Absolutely.
Influence the
preference. Thanks.
Yep.
Good call.
Anna Brunstrom. So I think I just wanted to point. I think the preferences and constraints are very different here.
Yep.
So those I think we really need to think about because the implications are so different.
Well, and I like the way that I actually like the way that Philip, I think it was Philip, put it. That we basically have, the supply comes from down here and the filtering comes from the top, right? So what you can do bubbles up, and then what you don't want to do pushes down. I think it's a good way to frame this or constrain this set of solutions that this makes this tractable. All right. Thank you very much.
I was just editing your slide. Oh, yeah, Michael. Michael, you're the last one.
I'll be quick. I think it's about who has what knowledge. You cannot have a system policy giving applications messages out of order if applications can't accept that. Applications may not know about me having a preference for Wi-Fi or not. So it depends on who has which knowledge. Really, that's my view on it. I mean, at least helps simplify this discussion, I think.
Okay. Is there anybody who didn't sign the blue sheets? Good. Okay, Michael, you get the last word. Thank you, everybody. If you've got comments on this topic, feel free to add them in onto the Etherpad or take them to the mailing list, and I will see you all in Singapore.
I sent out 2, but I'm getting 1 back. So. Either this.